The goal of this problem is to solve a network that involves Zener Diode. So we are going to use various values of the load resistance, our load. Our load will take a few values. 1 kilo ohm, 4 kilo ohm, 8, 16, and 32. So for each of these values, load resistance values, we are going to compute the output, which is the voltage, the output voltage here, call it V0. So let this voltage equal to V equal to 4 volt, and VI also equal to 4 volt. The resistance R would be 4 kilo ohm. So the characteristic of a Zener diode looks like this. So this is the voltage across the diode. That's the current through the diode. So we're gonna approximate the voltage by the forward voltage, forward bias. There's the diode's forward bias there, and the voltage here will be VD on, which is 0.7 volt. So let's say when the diode's reverse bias, VZ. So this is -2 volt over here. The new voltage here is -2. So when the diode, so the diode has 3 states, right? So we have a reverse bias, reverse bias, and here the diode is off when the current is 0. So the diode has 3 states. So it's either in the reverse bias, the forward bias, or the off state. So we are going to use this diagram to solve for the current here that I call I load. I call this current I1, call that current I, and I call the current here, I will call it I1. Okay, so the goal is so for each value, okay, so when it's forward bias, then looks like this, and ID will be positive. So this is forward the bias. Now when it's off, then there is no current. So let's do the reverse bias. So reverse bias. So for reverse bias, we still have this, the diode there, but in that case we have VZ, which is 2 volt in this case, and the current to the diode will be IZ, which is positive. So when it's in reverse bias, we are gonna find the current IZ and see if the current is positive or not. If the current is positive, then it's indeed in reverse bias. So I am going to assume one of these the state. So let's say that the diode is forward bias. Okay, so diode forward bias. So in that case, then we want the current to the diode will be positive. So if that's the case, then that condition and the assumption that we just made, that the diode is forward biased, is true. So I'm gonna redraw the network. I have the 4 kilo ohm here, 4K here, and the diode is assumed to be forward bias. So we have 0.7 volt and the current ID. So we have the resistor 1 kilo ohm for now, and we have the negative 4 volt here. So the voltage here will be equal to V0. So if I assume this is ground, then the voltage here will be negative 0.7 volt. Then this current I, so I call it I1. So I1 is equal to VI minus 0.7 divided by 4K. So that gives me VI, which is 4 volt. So 4 plus 0.7 over 4K, which is 4.7 divided by 4. So let me enter that in the calculator. So 4.7 divided by 4. So that gave me 1.175 million. So that's I1. Now let's find IL. So IL is minus 0.7 minus 4 volt divided by 1 kilo ohm, which is minus 0.7 plus 4 over 1 kilo ohm. So that gives me 3.7 million. So when we do KCL at this node, the node right there, so KCL at the node on top, that gives me I1 plus ID equal to I load. So I'm doing this to check whether ID is positive. So excuse me. If if ID is positive, then our assumption that the diode is forward bias is true. So ID, which is IL minus I1, that is 3.7 minus 1.175. So that gives me minus 3.7, so 2.53. So it's 2.525 milliamp. So in this case, ID is positive. So the diode is indeed in forward. So the diode is forward bias. So this we know we know I1, we know ID. So ID, which is the current I equal to ID, which is 2.525 milliamp. I1 equal to the value that we calculated there, 1.175 milliamp. Now the load current is 3.7 milliamp, and V0 is equal to minus 0.7 volt. Now let's change the load. So now our load equal to, what are the values we enumerated that we're going to use? 4 kilo ohm. So our load is 4 kilo ohm. So we're going to do the same thing. Now we still have 4 volt, so 4 kilo ohm. We have the diode here. So let's assume the diode is still forward. It's just an assumption, we're gonna check. So diode is forward bias. That means ID must be positive in that case. So we have, that's ID, and we have the load, so 4 kilo ohm, and the voltage source here just negative 4 volt, and the voltage here is V0. So still call this I, call it I1, and call this I load. So I1 is equal to, so the voltage here will still be minus 0.7 volt. So 4.7 divided by 4k is what we have before. So it's 1.175 milliamp. Now I load, which is 3.7 divided by 4 kilo ohm. So the 3.7 come from negative 0.7 minus 4 divided by 4k. So minus 0.7 plus 4 divided by 4k. So 3.7 divided by 4k. So 3.7 divided by 4, that gives me 0.93 milliamp. So that's the load current. So here you can see that ID, which is I load using the same KVL, right? So this is ID here, and I1 and ID go entering the node, and IL is leaving the node, so IL minus I1. So we have 0.93 milliamp minus 1.175 milliamp, which is obviously less than 0. So ID is less than 0. So the diode is not forward bias. Now, so let's check if it's a reverse bias. So let's assume diode is reverse bias. So in this case, we have the same network. So I'm just gonna copy this and paste and change the, so here change this into so this is VZ equal to 2 volt, and the current is IZ. So we want IZ to be positive. IZ might be positive. So what do we have? We have I1 is now here is 2 volt. So 4 minus 2 divided by 4k. So 2 divided by 4, which is 0.5 milliamp. Now I1, IL, the load current, which is 2 minus 4 divided by 4k. So that gives me 6 volt divided by 4 kilo ohm, which is 3/2, which is 1.5 milliamp. So the load current in this case will be 1.5 milliamp. Now, so we know that I1 must be equal to IZ plus IL. So the IZ is I1 minus the load current, which is I1, which is 0.5 milliamp minus 1.5 milliamp. So that's minus 1 milliamp, which is negative. So IZ minus 1 milliamp is less than 0. So the diode is now forward bias. So IZ is negative. So the diode is not reverse bias. That's what I mean. The diode is not reverse bias. So I mean the diode is off. That's the only state left. So then the diode is then off. So the diode is off. So when the diode is off, then we have this scenario. 4 kilo ohm, diode is off, it's open, and we have the 4 kilo ohm and the source here. This is 4 volt. So in this case, so I1 equal to I load, and then what is that equal to? Right, this is I load, so this is 4 volt. So let's write KVL around this loop. So minus 4 volt plus 8K times I load. Now minus 4 equal to 0. So IL equal to 8 volt divided by 8K, which is 1 milliamp. So for this case, IL equal to 1 milliamp equal to I load V0 is 4 times 1 milliamp, 4K times 1 milliamp. Okay, minus 4 volt. So V0 is 4 minus 4, which is 0. So the output voltage is 0 volt. And the diode current, right? So the current is equal to 0. So ID is 0 amps. Okay, now let's change the load. Let's change the load to 8K. So our load equal to 8 kilo ohm, and let's assume the diode is reverse bias. So that's just a guess. So that's what we're trying to do. So take the network here instead of drawing the whole thing again. So I'm gonna paste it here. So what we're going to do, we are going to change the load to 8 kilo ohm. So in that case, assume the diode is reverse bias. So I1 still 4 minus 2 divided by 4 kilo ohm. So that is 2 over 4, which is 1/2, 0.5 milliamps. Now let's calculate the load current. I load is equal to 2 minus 4 over 8. So that gives me 6 over 8, which is a 3/4. So milliamp. And when we write KCL at that node, so we have IL equal to IZ plus I1 equal to IZ plus IL. So I'm gonna find IZ, which is equal to I1 minus IL. So I1, which is 0.5 milliamp, minus 0.75 milliamp, which is less than 0. So the diode is not forward bias. So IZ minus 0.25 milliamp is less than 0. So the diode is not. Alright, so reverse bias, that means IZ must be positive. But that's not the case. So diode is not forward bias, reverse bias. That's what we assume. Reverse bias. So now then let's check. So let's check whether the diode is forward bias or up. So let us check. So whether the diode is forward bias. So in that case, what do we have? We have this. So you know what? I have this network. I'm just gonna paste it here. And this was 8 kilo ohm. And the diode is we assume now is forward bias. That means ID must be positive. So it's ID, and for forward bias this is 0.7 volt minus, because the minus polarity, the plus polarity is grounded. Okay, so we can find I1, which is 4 plus 0.7 divided by 4K. So that's what we have been doing. So 4.7 divided by 4 is 1.175 milliamp. Now the load current will be equal to minus 0.7 plus 4, right? So minus 4 divided by 8K. So that gives me 3.7 divided by 8 milliamp. So 3.7 divided by 8, that's 0.463 milliamp. So that is the load current. So ID plus I1 equal to I load. So ID equal to the load current minus I1, so which is 0.4, so it's 0.4625 25 minus I1, which is 1.175 milliamp. So ID is negative in this case. So this implies that the diode is not forward bias either. The diode is not forward bias either. So the diode is off. So in conclusion, for this case, in this case where our load equal to 8 kilo ohm, the diode is off. So the diode is off. Now what do we have? We will draw the network with the diode off. So this gives me 4 kilo ohm. Now the diode is off, so it's open. Now I have the 8 kilo ohm here, and I have the negative 4 volt, so 4 volt. This is 4 volt. So when we write KVL here, I have minus 4 volt plus 12k I. So let's say this is IL. So IL minus 4 equal to 0. So IL equal to 8 divided by 12. So 8 divided by 12 is equal to 0.667 milliamp. So which is equal to I1. This is I1. So the diode current is 0, and the output voltage V0 is 8 times, so 8 times IL minus 4. So that means, so it's 64 divided by 12 minus 4. So 1.33. So V0 is 1.33 volt. Okay, so ID is 0, IL equal to I1, so that is equal to 0.667 milliamp. So now I'm just gonna do the last one. So for the last one, what do we have? So we have our load equal to, let's do 32 kilo ohm. So we have, this is 4 kilo ohm. So you know what, let's do all of them. So I'm gonna do 16k. So 4 volt. I have 4 kilo ohm here. So 4k, 4 volt here. Now, what are we going to do? Let's assume that the diode is a reverse bias. Okay, so just gonna paste the network that I copied earlier. Alright, so this will be now 16 kilo ohm. So here we assume that diode, so that's our assumption. So assume diode is reverse bias. So in that case, we need to find the current I1. So I1 is 4 minus 2 divided by 4k, which is 2 over 4, just half, 0.5 milliamp. Now I load is equal to 2 minus 4 divided by 16, which is 6 divided by 16, okay, 6 volt. Okay, so 6 divided by 16, that gives me 0.375. milliamp. So I1 equal to IZ plus IL. Okay, so the diode reverse bias, that means we want IZ to be positive, right? So please keep that in mind. So that's why we need to find IZ. So IZ will be I1 minus I load. So I1 is 0.5 milliamp minus I load with 0.375 milliamp. So 0.375 minus 0.5, so that is 0.125. So IZ 0.125 milliamp, which is positive. So the current IZ is positive, so the diode is indeed reverse bias. So the diode is indeed reverse bias. So we know I1 0.5 milliamp, we know IL, which is 0.375 milliamp. So I know I, which is the current flowing against this what we call I. So I equal to minus IZ, which is minus 0.125 milliamp. And then V0 is 16K times IL minus 4. Okay, so 16 times IL, which is 0.375. So 16 times 0.375 minus 4. So that's 2 volt. So this is 2 volt. Okay. So finally, the last case. So our load equal to 32 kilo ohm. So I'm gonna assume that the diode is a reverse bias as well. Diode. So that's the assumption. So assume diode is reverse bias. So that means IZ must be positive. So we are going to find IZ and check whether it's positive or not. So going to copy this network, and I'm going to paste it down over here, and this is 32K. So for that, we know that I1 remains the same, 4 minus 2 over 4K, which is 0.5 milliamp. Now IL is 2 minus 4 over 32. Okay, so that's 6 divided by 32. So 6 divided by 32, that gives me 0.875, 0.87, so 0.1875. That's what my calculator gave me, 875 milliamp. So IL equal to 0.1875 milliamp, and then my IZ plus IL equal to I1. So IZ is I1 minus IL. So I1 0.5 milliamp minus 0.1875 milliamp. So as you can see, this is positive. So Lambda is 0.3125. So IZ 0.3125 milliamp is positive. So the diode is indeed reverse bias. Is indeed reverse bias. So what do we need to find? So we know that I equal to negative 0.32125 milliamp, and V0 will be equal to 32 kilo ohm times the current I load, which is 0.1875 milliamp minus 4 volt. So it's 32 times 0.1875 minus 4. Why we're getting the same thing? So I load equal to 0.1875 times 32. So this is 2 volt. So I think, how come I get 2 volt and here? So I load was equal to 0. So let's see. So let me double check out. 16 times 0.375 minus 2. So that's 4 volt. Oh no, minus 4. So this is 2. That's the other one is also 2. Okay, so that is so double check 16. So I load was 0.375 times 16, and this is 32, so it's half. That's why. Okay, so that's it. Okay, so we went through all the cases and we found all the voltages and current. So when you're given Zener diode, it's either going to be in reverse, forward, or it's going to be off. So you need to check the state, right? So you make the assumptions as we made in this problem, and then we're able to check and find the correct state of the diode. So thank you.